What if your phone became outdated not because Apple or Samsung released a new device, but because another country quietly built the network that will replace today's internet? While most of the world is still rolling out 5G, China has already crossed into the next generation. In late 2025, Chinese researchers achieved a live wireless transmission of 1 terabit per second, roughly 100 times faster than the 5G connection your phone uses today. But the speed isn't the biggest story. Behind that breakthrough is a race that could determine who controls the future of global communications. It's already forcing Washington to rethink its telecom strategy and bring together a 24-nation alliance to catch up. One of the countries in that alliance may surprise you: the Philippines. So how did China move this far ahead before most people even realized the race had begun? Here are the 6 reasons China is leading the global 6G race, counting down to the breakthrough that changed the world's telecom strategy. Number 6. The speed numbers are real and they're not close. Start with the number in the title because it has to be proven immediately or the whole video means nothing. In November 2025, researchers at Purple Mountain Laboratories, working with Southeast University, Pengcheng Laboratory, Fudan University, and China Mobile, demonstrated terahertz band wireless transmission that reached speeds in the range of 100 gigabits to 1 terabit per second, using frequencies between 300 gigahertz and 3 terahertz that current 5G networks can't touch at all. That range alone represents up to a 20-fold jump over 5G's peak transmission rate, according to the lab's own published figures. Then, in a separate trial reported in early 2026, researchers in Beijing's Huawei district ran what they described as the world's first 6G terahertz trial network, hitting a peak downlink of roughly 1 terabit per second. The benchmark the International Telecommunication Union has floated as a long-term target. Other teams, including China Mobile, Southeast University, and Fudan University, separately demonstrated real-time terahertz transmission above 100 gigabits per second, with dual wavelength systems reportedly reaching around 200 gigabits per second. The hardware side moved just as fast. In August 2025, a team from Peking University and City University of Hong Kong, publishing in Nature, unveiled the world's first all-frequency 6G chip, a thumbnail-sized piece of silicon, 11 by 1.7 millimeters, covering the entire spectrum from 0.5 to 115 gigahertz on a single chip. Covering that range traditionally required 9 separate radio systems. This one chip does it alone, at speeds above 100 gigabits per second, designed to slot into smartphones, base stations, drones, and other devices. Then, in February 2026, a joint team from Peking University, Pengcheng Laboratory, Shanghai Tech University, and the National Optoelectronics Innovation Center published results in Nature showing a converged fiber and wireless system, hitting 512 gigabits per second over fiber and 400 wirelessly. And in a simulated large-scale test, the system handled 8K video across 86 channels at more than 10 times standard 5G bandwidth. None of these are marketing slides. They're peer-reviewed, published results, run by named university labs with the hardware specs on the record. The 100 times faster claim in this video's title isn't a rounding trick. It's the documented gap between 5G's real-world ceiling, which tops out in the low single-digit gigabits per second for most commercial users, and what Chinese labs have already clocked in live terahertz trials running at up to a terabit per second. It also matters that these aren't rival labs working in isolation. Purple Mountain, Southeast University, Pengcheng Laboratory, Fudan, Peking University, and City U Hong Kong are effectively nodes of one coordinated national push, each publishing results that build on the other's work, rather than guarding them as trade secrets. But a fast chip in a lab is one thing. What happens when an entire country builds the legal groundwork to own the actual rulebook 6G runs on before anyone else finishes the paperwork? That's number 5. And it's the reason China's 6G advantage isn't going away when the hype dies down. Number 5. China owns nearly half the patents. Before the technology even exists, whoever writes the patents writes the rules everyone else has to license. According to the China Internet Development Report 2025, released by the Chinese Academy of Cyberspace Studies at the World Internet Conference Wuzhen Summit in November 2025, China held roughly 40.3% of all global 6G patent applications as of June 2025, more than any other single country on Earth. The same report placed China's 6G industry on track to exceed 1.2 trillion yuan, or about $168.5 billion, in market scale by 2030, with industrial internet applications making up 40% of that and smart cities another 30%. That patent share isn't an accident of paperwork. Han Juk, deputy head of the China Communications Industry Association, said the volume reflects years of sustained investment in communications technology and hands China real influence over how 6G standards get written and industrialized. Historically, whoever controls the foundational patents on a wireless standard collects licensing fees from other countries' manufacturers for decades afterward. That's exactly how Qualcomm built its position in 4G and 5G. China backed the patent filings with actual national infrastructure. The country established the IMT 2036G Promotion Group back in 2019, years before most Western governments treated 6G as more than an academic exercise. By January 2026, Chinese officials confirmed the country had entered the second phase of its 6G trials after clearing more than 300 distinct technical milestones, according to a Ministry of Industry and Information Technology spokesperson cited by CGTN. As part of that push, regulators have moved to formally allocate 6 GHz spectrum for 6G use, spectrum that has to be cleared and assigned years before any commercial network can legally switch on. For comparison, the US has no single country patent share anywhere close to 40%. A May 2026 industry report on US 6G readiness pointed to the ATIS NextG Alliance, AT&T, Verizon, T-Mobile, Microsoft, Samsung, and Ericsson. As the American answer, but noted the real challenge through 2028 is turning existing Qualcomm and NVIDIA hardware strength into actual standard-setting contributions, since patent volume, not chip performance alone, decides who controls the market once the standard locks in. A patent portfolio is powerful, but it's still theoretical until you can prove the technology works somewhere no ground network can reach at all, off the surface of the planet entirely. That's number 4, and it's the point where China stopped testing 6G in a lab and started testing it in orbit. Number 4, China already has 6G running in space. 2 years before most people started paying attention to 6G at all, China had already put it into orbit. On February 3, 2024, China Mobile, the world's largest mobile carrier by subscriber count, launched 2 satellites into low Earth orbit, one carrying 5G technology and the other called StarCore, hosting what the company described as the world's first satellite core network built on a distributed autonomous architecture for 6G. Developed jointly with the Innovation Academy for Microsatellites at the Chinese Academy of Sciences, using entirely domestic software and hardware, it supports in-orbit software reconstruction and automated network management from roughly 500 kilometers up. Close enough to deliver meaningfully lower latency than the geostationary satellites parked at 36,000 kilometers that most satellite internet still relies on. The point of putting 6G architecture in orbit isn't novelty, it's coverage. China Mobile has been explicit that low Earth orbit satellites are meant to close the gaps ground-based networks can't reach, extending high-bandwidth internet into remote regions as one genuinely integrated space-to-ground network. That work kept advancing. In August 2025, researchers at Pengcheng Laboratory and the Harbin Institute of Technology's Shenzhen campus reported a breakthrough in digital beamforming for low Earth orbit satellites, with field tests showing signal-to-noise gains of up to 5.5 decibels on transmission and 2.6 on reception across dozens of live orbital tests. Analysts describe it as a direct step toward extending China's terrestrial computing network into space itself. The applications aren't hypothetical either. At a test site in Nanjing, monitoring systems running on 6G's combined sensing and computing capability reportedly identified an unauthorized drone in the airspace in just 1/10 of a second, instantly displaying its model and key characteristics, according to reporting from Xinhua. That's not a speed test, that's a live sensing application already running on early 6G infrastructure, and it points directly at what's coming next. Because putting a fast signal into orbit is impressive, but the real story isn't the speed at all. It's what China decided to build directly into the network itself, from the ground up. Something no previous generation of wireless technology ever did. Number 3 is where 6G stops being about your phone and starts being about the machines it's built to talk to. Number 3, 6G isn't being bolted onto AI, it's being built around it. Every previous wireless generation was designed first and AI got added on top of it later, as an afterthought running through an app. China's 6G roadmap flips that order entirely. According to China Media Group's own framing of the national 6G program, the technology is explicitly designed to integrate communications, sensing, computing, AI, big data, and security into a single architecture. Not layers stacked on a dumb pipe, but one system built to support intelligent agents and inclusive AI from the first line of the standard. Huang Yuhong, head of the China Mobile Research Institute, has said publicly that 6G requires genuine breakthroughs in network architecture, developing alongside 5G Advanced rather than simply replacing it. Wen Ku, chairman of the China Communication Standards Association, frames the entire 6G era around a two-way empowerment of AI and networks, where AI's pace of development is actively shaping how the standard itself gets written. Industry analysts see the same pattern. Liu Dingding, a veteran technology analyst cited by the Global Times, has said 6G's biggest leap isn't raw speed at all. It's connectivity that seamlessly merges ground infrastructure, satellites, and aerial platforms into one network. Specifically because that scale of connection is what next-generation applications like digital twins, world models, and AI agents actually require to function at all. Infrastructure-wise, that likely means 6G networks combining ordinary ground-based stations with low Earth orbit satellites and even high-altitude platforms, extending coverage into remote regions with far fewer blind spots than anything 5G ever offered. The projected scale backs up the ambition. The IMT 2030 Group's own forecast put connected 6G terminals at more than 30 times today's levels by 2040, with monthly data traffic surging over 130 times in the same period. Numbers that only make sense for a network designed to carry billions of autonomous devices and robots, not just phones. That's the real reason this matters beyond a speed benchmark. Remember the humanoid robots already shipping out of Chinese factories by the tens of thousands, and the free AI models already running on hardware around the world? Those systems don't just need a fast connection, they need a network that was built, from its foundation, to understand what a machine is doing and respond to it in real time. China isn't building 6G to make downloads faster, it's building the nervous system for everything else it's already deployed. But a smart network design is still just a blueprint until somebody actually builds and sells the hardware that runs it in real networks, in real countries, right now. And on that front, the company that will physically build a huge share of the world's 6G base stations has already won the fight one generation early. Number 2 is that company, and its lead isn't a forecast. It's already sitting in Dell'Oro Group's revenue numbers today. Number 2, the company that will build 6G already runs global telecom infrastructure. Patents and lab breakthroughs decide what 6G looks like on paper. Revenue share decides who actually builds it in the ground. According to Dell'Oro Group, the analyst firm that tracks global telecom equipment, Huawei reached roughly 41% of global revenue share by early 2026, up from about 31% in the first half of 2025, despite ongoing geopolitical restrictions in multiple Western markets. Dell'Oro data shows Huawei ranks as the top supplier by revenue across all 6 major infrastructure segments it tracks, a spread almost no competitor matches. Omdia data separately shows Huawei ranked first in radio access network share across 3 of the world's 5 major regions. Add ZTE, and the combined Chinese share of the global telecom equipment market climbs well past 40%, even excluding Huawei's own domestic Chinese revenue. That matters because 6G won't arrive as a single global switch flip. It will roll out network by network, built largely by whichever vendors already hold the contracts and operator relationships. Nokia, Ericsson, Cisco, and Samsung remain real competitors. But heading into the 2026 to 2031 window, most forecasts flag as the critical 6G standardization period. Huawei is the only vendor selling meaningfully across the entire infrastructure stack at scale. That combination, Chinese labs setting the speed records, Chinese researchers filing 40% of the patents, and Chinese vendors already building most of the physical network hardware the world uses, is why analysts increasingly describe 6G less as a race China might win, and more as a transition China is already positioned to run. Because a fast chip is one thing, a patent share is another, a dominant equipment vendor is a third. But when all 3 line up inside a network built around AI, robotics, and autonomous systems from the ground up, and your own country's roadmap is still described as less clear by your own analysts, that's the moment a government stops watching and starts scrambling. Number 1 is that scramble, happening right now, and it includes a country a lot closer to home than you'd expect. Number 1, Washington just built a 24-nation alliance because it's already behind, and the Philippines is in the room. On July 28, 2026, the Trump administration launched a formal international partnership with more than 20 allied governments specifically to coordinate 6G development and counter China's growing influence over next-generation telecommunications, according to reporting first published by Politico and confirmed by multiple outlets since. The National Telecommunications and Information Administration, led by Ariel Roth, is running point, describing the goal as securing leadership in global communications before 6G begins replacing 5G sometime in the 2030s. The list of governments that signed on tells its own story: Albania, Australia, Canada, Costa Rica, Czechia, Denmark, Estonia, Finland, France, Germany, Greece, Honduras, Italy, Japan, Latvia, Lithuania, Norway, Panama, Paraguay, the Republic of Korea, Romania, Sweden, the United Kingdom, and the Philippines. The joint call to action from the group commits participating nations to building 6G systems that are open, interoperable, secure, and AI-supported, working with trusted partners years ahead of commercial deployment, rather than negotiating from behind once China has already locked in the standard. The timing isn't a coincidence. The next World Radio Communication Conference, where the International Telecommunication Union settles binding global decisions on wireless spectrum and standards, is scheduled for 2027. And it's being held in Shanghai. Analysts covering the alliance's formation have been blunt about the uphill climb it faces. Shan, a telecom analyst quoted in the Qatar Tribune's coverage, noted China has already established a pipeline of more than 300 key 6G technologies, while the American roadmap remains far less defined and still at an early stage. The South China Morning Post reached a similar conclusion, describing Washington's counter-effort as facing real short-term challenges precisely because so much of China's technical and commercial groundwork is already in place. This is the moment that closes the loop on everything before it. A country that spent years quietly filing patents, launching test satellites, and building AI directly into its next-generation network standard didn't need one dramatic announcement to take the lead. It built the lead one trial, one satellite, one patent at a time. The rest of the world only organized a response once the gap was already wide enough to see. The Philippines signing onto that alliance isn't a footnote. It's a signal the country is being pulled into the middle of a fight over whose networks and standards the next decade of global communication runs through. Putting it together. Go back to that number from the opening. 1 terabit per second in a live trial, roughly 100 times faster than the 5G signal reaching your phone right now. That speed record was never the whole story. It was the visible tip of a system China had been building for years, across patents, satellites, and network architecture, with a Trump administration alliance now racing to respond before the rules get written without American input. The same terahertz chip technology validated in a Beijing lab underpins the patent applications, now sitting at 40.3% of the global total. The same satellite architecture tested in low Earth orbit in 2024 is the blueprint for the space-air-ground network China's engineers say 6G is built around. The same AI-native design philosophy will run on hardware from a company that already controls 41% of the world's telecom equipment revenue. And all of that together is exactly what pulled 24 governments, the Philippines included, into an alliance most wouldn't have needed 5 years ago. None of this happened by accident. It's a decade-long bet that the network itself, not just the chip, the model, or the robot, is the layer that decides who controls the next era of global technology. Drop a comment. Which of these 6 surprised you most? The terabit test already running in a Chinese lab, or your own country joining an alliance built because it's already behind? Because 6G was never just about how fast your phone downloads a video. It's about who controls the network everything else. The AI, the robots, the satellites, has to run through.